In this tutorial, we're going to talk about percent markup problems. Percent markup problems and percent markdown problems are technically from a pre-algebra course. However, you can see these also in algebra courses or elementary algebra courses. Some colleges or high schools have them as Algebra 1 or Algebra 2 courses. Now, the group that this belongs to, like I just mentioned, is algebra. The skill that we're dealing with here is a percent markup with the percentage rate unknown. Here are the prerequisites that you have to have prior to doing this type of problem. You should be able to solve linear equations in one variable. Forgot to write that in there. You should be able to write a linear model given some type of application. You should be very familiar with percents. What does it mean to have a percentage like 13%? You should know that that's written as 0.13, that type of thing. Arithmetic, obviously all of arithmetic is required for any of the algebra group problems. And then you should be familiar with the problem solving process because this is an application. All applications kind of can be solved using modifications of this problem solving process, which means essentially that we're going to read the problem, understand what's going on. We might have to draw a picture in that second step. In this problem you don't have to draw a picture, but other problems you might have to. The third step is always labeling your unknowns. Fourth step is writing equations using those unknowns. You might write 1 or 2 equations, or even 3 or 4, who knows. Then solve those equations and finally state your conclusion. The best way to approach this style of problem is just to talk about a generalized problem here. So let me say that we have a $100 shirt that we want to put on sale, or that we want to sell, I suppose. Maybe we paid $100 for it. We want to make a profit. So let's sell it for $120. And the question is, how much did we mark it up? In other words, what did we tack on in percent wise to that $100 to get to the $120 that we're selling it for? A lot of people already know we tack on 20 bucks, right? We took that $100 and we tacked on 20 bucks. But that's actually not what I'm asking. I'm not asking how much did you tack on. I'm asking what percent did you tack on. 100 is a nice number because it's very easy to determine what percent we marked it up by here. If we only tacked on 20 bucks, that's just 20%, right? Talking in terms of 100s makes it very easy for people to do these problems. So 20% of that 100. Well, let's get even more mathy here. 20% of means 20% times, or 0.20 times. So this is just the same thing as saying 100 plus 0.20 times 100 is equal to 120. Of course, this is all kind of useless if we don't write this in a general format for all problems. So I want you to notice something here. We had an old price of $100 for our shirt, and we tacked on 20% of that old price to arrive at a new price. So let me write that down. Turns out that this is a theorem. Well, okay, it's not much of a theorem, and you might see it in some textbooks and might not see it in most. But this is like a markup theorem. This is when you're doing a percentage markup. That all markup problems kind of have this feel to them. They have an old price plus a certain percent of an old price will become the new price. You could do this with any type of problem. And in fact, we'll go ahead and do this with the problem that we've been given. So I recently edited and published a textbook for our intermediate algebra course at Columbus River College. If you purchase the book brand new online, it costs $55, and this includes shipping. However, if you purchase the textbook at our bookstore, it costs $65. What is the percentage markup that the bookstore is charging? So remember, how markup works is you have an old price, and what they do to that old price, the initial price I guess you can call it, is they tack on a certain percent to it. And that's how they arrive at what price they end up selling it for, their new price. Go to any type of bookstore or product store, go to an electronics store. They buy their TVs from a manufacturer and they put a percentage markup on it, and then sell it to you for a higher price because you can't access the manufacturer. So here we go. The old price in this situation happens to be $55. They're going to tack on a certain percentage, and I'll call that R, because that's usually the letter we reserve for percentage rates. Certain percentage of that old price, and it's going to become the new price, which is $65. Technically, this is not written in a very nice format. You usually write 55 before the R. In other words, the numerical value is always written prior to the variable. So maybe I'll clean that up as an additional step here. And now I will subtract using the subtraction property of equality. I'll subtract 55 from both sides. And that will give me that 55R is equal to 10. And now I will divide both sides using the division property of equality. Divide both sides by 55 to rip that 55 off that R. This is just solving a linear equation in one variable. On the left-hand side, 55 over 55 turns into 1. So that's essentially 1R, or in other words, R. And the right-hand side, well, that 10 over 55 will reduce, but when you're talking percentages, you usually rewrite this percentage or this fraction as a percentage at first as a decimal representation, and then we'll change it to decimal or to percentage form. Grabbing a handy dandy calculator here, we just type in 10 over 55, or you could do this longhand. I get 0.18181818 on forever. You can understand the pattern. So I'll write this as rough. Actually, I'll write it as exactly equal to 0.18, and I'll put the over bar over the 18, meaning copy, paste, 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 right? 181818. And as a percentage, remember you move that decimal over twice, so this is going to be 18.18 on forever %. And most people don't want to say 18.18 on forever %, so we'll round this to the nearest tenth of a percent to become 18.2%, roughly. That's a rough percentage increase. That's how you do a percentage increase problem.